The James Webb Space Telescope, JWST, is nothing short of revolutionary. Since its launch in December 2021, it has become a game-changer in the world of astronomy and astrophysics. The capabilities of JWST have already begun to defy expectations, revealing discoveries that challenge not only our understanding of distant galaxies but also the fundamental principles that underpin much of modern cosmology. Among its most incredible revelations are 15 galaxies that seem to predate the Big Bang itself. This finding is staggering in its implications. It forces scientists to revisit everything they thought they knew about the age of the universe, the expansion of space, and even the very nature of reality. The discovery of these ancient galaxies is no small feat. For decades, our understanding of the universe's history was shaped by the Big Bang theory, which suggested that the universe began as a singular, immensely hot and dense point around 13.8 billion years ago. From that point, space expanded, cooled, and eventually formed stars, galaxies, and all the structures we see today. This theory has been the backbone of our understanding of the cosmos for nearly a century, but now, JWST is forcing us to reconsider whether this model is accurate at all. Some of the galaxies that the telescope has observed are older than the universe itself, existing long before the Big Bang was thought to have occurred. How is this possible? And what does it mean for our understanding of cosmic history? The implications of these discoveries are profound. If galaxies existed before the Big Bang, it challenges the very foundation of the Big Bang theory. After all, if these galaxies can exist before the supposed beginning of the universe, then what does that say about the nature of time, space, and the origins of everything? It's an exciting and unsettling thought for scientists, as they now face the daunting task of reconciling these new observations with their long-standing models. JWST has opened the door to a new era of cosmic exploration, one where the questions we thought were answered may now need to be rewritten entirely. Since its launch, JWST has given scientists an unprecedented view of the universe, uncovering phenomena that were once thought to be impossible. It has captured the most detailed images of distant galaxies and nebulae ever taken, revealing incredible details that were previously beyond our reach. And yet, despite these astounding images, JWST's true impact lies in the questions it raises. As researchers sift through the data sent back by the telescope, they are realizing that many of the assumptions they've made about the universe's history might be wrong. In some cases, these findings may even force a complete overhaul of our understanding of cosmology. At the heart of this challenge is the issue of redshift, a key observation that has long been used to measure the distance between galaxies and determine their speed of movement. Redshift refers to the stretching of light waves as they travel through space, causing their wavelengths to become longer and shift toward the red end of the spectrum. This phenomenon has been interpreted as a sign that galaxies are moving away from us, which in turn has been used to support the theory that the universe is expanding. The greater the redshift, the further away a galaxy is thought to be. However, JWST's observations have cast doubt on this interpretation, suggesting that redshift might not be caused by the expansion of the universe at all. This challenge to the redshift theory opens up a whole new world of possibilities. What if the redshift is not a sign of galaxies moving away from us, but instead the result of light interacting with matter or radiation fields in space? This idea was first proposed nearly a century ago by Swiss physicist Fritz Zwicky, who suggested that light could lose energy as it travels through space, causing it to become redshifted. If Zwicky's theory is correct, it would mean that the universe is not expanding as we thought, and that the Big Bang theory might be entirely wrong. It's a radical idea, but the more scientists analyze the data from JWST, the more it seems like a plausible explanation. The consequences of this theory are nothing short of revolutionary. If the universe is not expanding, it would mean that many of our fundamental assumptions about the cosmos are incorrect. The idea of a universe that began with a massive explosion and then expanded and cooled over billions of years would no longer hold water. In fact, this would imply that the universe has existed in some form forever, with no true beginning or end. This could mean that the universe is infinite, or that it exists as part of a much larger, multidimensional structure that we currently can't comprehend. the implications for our understanding of time, space, and the nature of reality would be staggering. But even more startling than this challenge to the Big Bang Theory is the discovery of galaxies that appear to be older than the universe itself. JWST has captured images of galaxies that, according to current models, should not exist at all. These galaxies are thought to be 13.6 billion years old, which places them just 200 million years after the supposed Big Bang. However, this doesn't add up with our understanding of the universe's history. How could galaxies form so quickly after the Big Bang, when the universe was still a hot, dense soup of particles? And how could these galaxies possibly be older than the universe itself? These are questions that scientists are still struggling to answer. One possible explanation for this anomaly is that the redshift measurements for these galaxies are incorrect. If the redshift is not caused by the expansion of the universe, then the galaxies might be much closer than we originally thought. This could mean that they are not as old as they appear, and that they formed in a different way than we currently understand. Alternatively, it's possible that these galaxies are simply much older than we imagined, and that our understanding of galaxy formation needs to be completely revised. Either way, JWST has opened up a whole new set of questions about the early universe that could take decades or even centuries to fully answer. In addition to these mind-bending discoveries, JWST has also revealed the presence of supermassive black holes that seem to defy the laws of physics. These black holes, some of which are believed to be older than the universe itself, are a true mystery. How could such massive objects form so quickly in the early universe? And how can they continue to exist without violating the laws of physics as we understand them? These are questions that scientists are still grappling with, and they may eventually lead to a complete rethinking of our understanding of black holes and their role in the cosmos. At the same time, JWST's findings are challenging our understanding of the expansion of the universe itself. If galaxies are not moving away from us as we thought, and if the universe is not expanding, then what does this mean for the future of the cosmos? For decades, scientists have speculated about the ultimate fate of the universe, with theories like the Big Freeze, the Big Crunch, and the Big Rip all offering different possibilities. But if the universe is not expanding, then these theories might need to be thrown out as well. Perhaps the universe will continue to exist in its current state, or perhaps it exists in a completely different way than we can currently comprehend. Whatever the answer is, it is clear that JWST is pushing us to think about the cosmos in entirely new ways. In the midst of all this uncertainty, there is one thing that remains clear: JWST is revolutionizing our understanding of the universe. It is forcing scientists to confront uncomfortable truths and reconsider long-held theories. It's a thrilling time for anyone interested in cosmology and the mysteries of the cosmos, as JWST continues to uncover new and exciting discoveries that challenge everything we thought we knew about the universe. The age of the universe, the nature of galaxies, the behavior of black holes, all of these concepts are being re-evaluated in light of the new data coming from this incredible telescope. We are standing on the precipice of a new era of discovery, one in which the answers to the greatest questions about the universe may be far more complex than we ever imagined. But even as scientists grapple with these new challenges, there is a sense of excitement and wonder that comes with the uncertainty. For the first time in history, we have the tools to look back to the very beginning of the universe, to witness events that happened billions of years ago, and to challenge our understanding of time and space. With JWST leading the way, we are embarking on a journey of discovery that promises to redefine our place in the cosmos. Of course, as with any scientific revolution, there are those who resist change. Some scientists are still clinging to the old theories, unwilling to accept the implications of JWST's discoveries. These scientists argue that the telescope's findings are merely anomalies that will eventually be explained away. They insist that the Big Bang Theory, with all its flaws, is still the best explanation for the universe's origins. But as more and more evidence comes in from JWST, it is becoming increasingly difficult to ignore the possibility that we are on the brink of a fundamental shift in our understanding of the cosmos. The debate is far from over. There are still many questions to answer and many mysteries to unravel. But one thing is certain: the James Webb Space Telescope is changing the way we see the universe, and it is opening up a whole new world of possibilities for the future of astronomy. As we continue to explore the depths of space, we may find that the answers to the most profound questions about the universe are more elusive and more mind-boggling than we ever imagined. And in the process, we may just find that the more we learn, the less we truly understand. In the coming years, we can expect even more discoveries that challenge the very fabric of our understanding of the cosmos. New galaxies, new black holes, and new phenomena that break all the rules of physics are waiting to be uncovered. And with each new discovery, we are one step closer to unraveling the greatest mysteries of the universe. But whether we ever reach the ultimate truth, or whether the universe remains an endless source of wonder and mystery, remains to be seen. The future of cosmology is wide open, and with the James Webb Space Telescope leading the charge, there is no telling just how far we will go.